Today we're going to look at the idea of motion, and we're going to dive a little bit deeper. We've kind of been talking about it with position, velocity, acceleration, and now we're going to look at more challenging problems. So first of all, I would like to clarify a few of the vocabulary words and notation. So position. Position is many times represented as x of t. Or sometimes you might see it as notated as s of t, and both represent the position of a particle. And so if you want to determine where a particle is located, so you want to find its location. This is the function which you would use, determine where a particle is located, and many times it will be along the x-axis. So you'll have it moving what we would call rectilinear, which is basically a horizontal movement back and forth along the x-axis. And we would be able to find the location at any time t. Now sometimes the location will be described as a vertical movement along the y-axis. But basically, just to remember, position is location. Now, velocity. Velocity is represented as v of t, and we know that this would be the first derivative of position, and we could notate it in this way. Now, velocity determines how fast the position of the particle is changing at time t. Now, because velocity can have a sign, that means it can be positive or negative, velocity will give, well, that sentence does not make much sense, does it? Let's try that again. Whoops. As you can tell, I just got a new iPad and I'm learning about how to use it all. It's actually quite exciting. So it determines how fast the position is changing at time t, as well as the direction of movement. And the third aspect of motion that we will focus primarily on is acceleration. Now, acceleration can be represented as the derivative of velocity or the second derivative of position. And acceleration determines how fast the velocity is changing at time t. Now the sign indicates if the velocity is increasing or if the velocity is decreasing. The sign indicates if velocity is increasing or decreasing. Now, I'm going to define a few vocabulary terms that when you see these words, this is what you should think of. So if we're going to say that if x of t represents the position of a particle along the x-axis, any of the following statements would be true. So initially means when the time is equal to 0. So if you see that word, it's t is set equal to 0. At the origin means the position of the particle is equal to 0. Or we could say that x of t is set equal to 0. Okay, let me scroll this down a little bit. Whoa, here we go. Now, at rest indicates when the velocity is equal to 0. So rest means that the velocity is 0. If the velocity of the particle is positive, then the particle is, well, let me scroll. There we go. That's a better viewing window. If the velocity of the particle is positive, then the particle is moving to the right in this instance because we are moving along the x-axis. Now, if we're moving in a different direction, like vertical, then it would be up. So we have to read it in context of the problem. If the velocity of the particle is negative, then the particle is moving to the left. To find average velocity over a time interval, then what you would do is divide the change in position by the change in time. Position by the change. So in other words, we would have x of A minus x of B, so that would be the change in position from 2 points in time all over A minus B, okay? Okay, let me scroll it back here. So number 7, if instantaneous velocity is the velocity at a single moment, instant in time, okay? If the acceleration of the particle is positive, then the velocity is increasing. If the acceleration of the particle is negative, then the velocity is decreasing. In order for a particle to change direction, the velocity must change signs. Okay, so let's do an example together. So let me move to my next slide then here. So problem 2 here. Let me get it in a viewing window. There we go. One way to determine total distance traveled over a time interval is to find the sum of the absolute values of the differences in position between all the resting points. Well, key words here is total distance traveled over a time interval, okay? And we will add up the absolute values. Basically, this is giving the example of when a runner, if you run out and back, you didn't run 0 miles. That would be your displacement, your change in position. But rather, your total distance traveled would be the sum of the distance out and then the sum of the distance back. So let's say we're looking at a function algebraically. X of t is 1/3 t cubed minus t squared minus 3t plus 4. So find the total distance traveled. Well, I need to find out when I am changing directions, and we just learned to find out when we change directions, we take the velocity and we'll set that equal to 0. So the velocity would be t squared minus 2t minus 3 is equal to 0. And so that is easily factored, t minus 3, t plus 1. And so that we can see then the zeros of this function are at 3 and at -1. Well, we realize that -1 in context of this problem is not possible because we cannot have a negative time. So if I looked at a velocity, whoops, I'm sorry, I made a mistake right there. It's not v prime. There we go. It's just if we looked at a velocity sign chart. So we're starting at when the time is 0, and then we're going to change directions at 3. So what I'm going to do is I want to determine the sign of velocity. In other words, is the particle moving to the left or is the particle moving to the right? And I also want to determine the sign in the interval greater than 3. So I would take a number between 0 and 1 and substitute it into velocity. Now an easy number might be 1. So what is v of 1? Well, I would go 1 squared, which is 1. 1 minus 2 is -1. -1 minus 3. So we know that the sign is negative. And then if I choose a number greater than 3, for example, like 4, 4 squared 16, minus 8 is 8, a minus 3 is 5, so that is positive. So we know that the sign changes from negative to positive. So in other words, my function is decreasing, and then it rests, it stops, and then the function is increasing, okay? So what we can say then is that we can find the displacement from 0 to 3 and add that up to the displacement from 3 to 6 in this example. So I want to find the change in position. So I do that by using my position formula. So I'm going to go x of 3 minus x of 0, and that will tell me the change in position. And so I must plug these numbers into this function. And so I'm going to have 1/3 times 3 cubed minus 3 squared minus 3 times 3 plus 4. And And then, I take that quantity and subtract it from x evaluated at 0, which I can clearly see is just 4. So 3 cubes, 27, divided by 3 is 9. 9 minus 9 plus 4, okay, and minus 4. So I end up with negative 9 plus 4 is negative 5, minus 4 is negative 9. So that would be the displacement. Now, so the total distance traveled, if I take, so this is x of 3 minus x of 0, x of 0. And so the absolute value of that then would be 9. Now let's look at the change in position from x of 6 to x of 3. Okay, and so this change in position then I would be 1/3 times 6 cubed, oh dear, times 6 squared minus 6 times 3 plus 4. Okay, now I just found the value of x of 3, and x of 3 was negative 9. Nope, x of 3 actually was negative 5. Okay, so I'm going to have to do my mathematics on this problem, and I wish I would have figured this out before starting the video, so I'm pulling up my calculator real quick, and 6 times 6 times 6 is, 6 times 6 equals, 216 divided by 3 is 72. So 72 minus 36 minus 18 plus 4. So that quantity plus 5. So 72 minus 36 minus 18 plus 4 is 22, plus 5 is 27. So that means the distance traveled in the second interval is 27. So my total distance then would be 9 plus 27, which is 36. Now, were units given to me? No, they were not. So I would just say 36 units traveled. Okay, now that I have done that problem, I would like you to do the second problem, the entire problem, so numbers 1 through 4.